Welcome to another exercise in a workbook statistics. This time focusing on an exercise on a normal distribution. So let's have a look at the exercise. A company produces neckties with a standard length of 50 centimeters. The machine, however, does not always work exactly, so that the length can be considered normally distributed with a standard deviation of 1.7 centimeters. And here we already have the most important information. We're working with the normal distribution. Well, let's have a look at our tasks. So the first part is, what is the probability that a necktie is made too short? That is shorter than 47 centimeters. Second, starting with a length of 53 centimeters, the necktie is no longer considered standard but extra long. What is the probability that the machine incidentally produces extra long neckties? And finally, all neckties with a length between 49.3 centimeters and 50.7 centimeters are considered first choice. The rest is considered substandard. Each week, 5,600 neckties are produced. How many substandard ties are produced during a normal week? Well, we already know it's about normal distribution. We have most of the important information standing here. So let's start with our first part. Here the question was on the necktie being too short, so being shorter than 47 centimeters. And we know the average, the mean is 50 centimeters, the standard deviation 1.7 centimeters. So we can start by standardizing the 47 centimeters by subtracting the mean and dividing by the standard deviation. This gives us a value of minus 1.76. The phi, the big phi in front, means we have to look up this value in the table for the standard normal distribution. However, there's one big problem. The table does not contain negative values. So what to do? Well, we can more or less like pull the minus in front of it, meaning instead of looking up the negative value, we put one minus in front of it and then leave off the minus. So this part is transformed into that. The 1.76 we can actually look up in the table. There we're going to find a value of 0.9608. So subtracting this from 1 yields us a final result of 3.92% that a necktie will be too short. Well, that was already the first part, so we can carry on directly with the next part, with part B. And in B, we're looking for the probability that one of the neckties is too long, that it is larger than 53 centimeters. Well, we could start and first off taking the counter probability to make this larger or equal to into smaller or equal to, which we would need if we want to, well, again, standardize the 53, look the value up in the table and so forth, as we did in part A. But if we think clearly, we already know the answer to this question. Because in A, we were with 47 centimeters. Now we were at 53. In both cases, I'm 3 centimeters away from the average. So smaller than 47 is actually exactly the same as larger than 53. So instead of calculating this, we could calculate that one. And this one we already calculated in part A. So the answer here is also 3.92%. A necktie being too long. Well, that was a quick and easy part, so let's continue directly with the third and final part, with part C. And here we wanted to know how many of these 5,600 produced neckties actually fulfill the requirements set. Here again we have two possibilities. We could set the whole interval with 49.3 centimeters to 50.7 centimeters, or we again see that both are 0.7 centimeters away from the mean. Whenever we have this, we can use a shortened version. The shortened version here in this case is 2 times and then probability of x being smaller than the lower bound, than 49.3 centimeters. So we're going to calculate only this one probability, saving us the hassle to do one additional. The mean and the standard deviation are still the same as before. So we're going to standardize the 49.3 centimeters by subtracting the 50 as a mean, dividing by the 1.7 for the standard deviation, giving us here again a value of negative 0.41. To get rid of the minus, I'm replacing this in front with 1 minus phi of 0.41. And the 0.41 I can look up in my table, giving me there a value of 0.6591. So I'm going to subtract this here off and get the 0.3409 as a final result for this probability. However, as we see here, I have to multiply this probability with 2. That's still from the simplification, and with the 5,600 neckties produced. I'm going to do this. I get as a final result 3,818.08. So we could say roughly 3,818 neckties fall within this criterion. Well, that was then it. That was the whole exercise. I hope you enjoyed it. I say goodbye and see you next time.